Hi, this is the story of me selecting, then building, then installing a low-cost, high-quality tape head preamplifier for my vintage reel-to-reel tape recorder, the one that's shown playing in the background. Of course, there's already a tape head preamplifier inside the tape recorder, but I decided I wanted something that sounded better. I hope you find it interesting, but a word of warning. If you want to try this for yourself, you need to have a good understanding of hi-fi circuit boards and the ability to use a soldering iron competently. You also need to understand electrical safety and the dangers of working with mains 240 volt electricity. And finally, at some point, you'll have to cut into the internal wiring of your beloved reel-to-reel and to modify it. So this project is not for the faint-hearted. I decided to do this YouTube mostly as a slideshow rather than a series of video clips. I hope you agree that makes it easier to understand. Also, I didn't think videos of me soldering or cutting wires would be very entertaining. In using a reel-to-reel, I'm not interested in recording live music, and also I'm not interested in transferring music from one source to a tape, for example from a vinyl record. It seems to me something will inevitably get lost in the copying process. But I am interested in listening to commercial reel-to-reel tapes as a source of music, and there are basically two types. The first is 4-track, 7.5 inches per second, quarter-inch tapes that were released commercially by lots of famous artists in the years of the 50s, the 60s, the 70s and the 80s. There's quite a lot of these available on the market from a few sellers on eBay, particularly from the United States. The prices vary a lot between say $20 up till several hundred, depending on how popular the artist and the music was. When I bought my first tape deck, I got about 100 of these thrown in, mostly classical, but some jazz. The second type are new, meaning brand new, 2-track, 15 inches per second, quarter-inch tapes that are copied directly from stereo studio master tapes. These use modern improved magnetic tape formulations which result in a much better frequency response and a much higher output. There are relatively few suppliers and the costs are high, about $500 a tape. The 15-inch Studio Master tapes have received almost unanimous highly favourable reviews for sound quality, even though the price is very high. And I decided that they represent a practicable state of the art for sound reproduction, so I bought a few, 4 so far. I also bought a tape deck, a vintage Technics RS1500 from eBay, capable of playing both 2 and 4-track tapes, at 7.5 and 15 inches per second. Other decks are typically 2 or 4-track. But when I played the Studio Master tapes on the tape deck, the sound was slightly disappointing. It lacked the dynamism I was expecting, having grown familiar with the best 7.5 inches per second vintage commercial tapes. So I jumped down another audiophile rabbit hole of disappointment stroke improvement. My conclusion was that the master tapes were actually good, and so were my preamplifier and speakers. But the most likely candidate for improvement was that the replay electronics within the tape deck were not good enough for modern tapes. Of course, this logic isn't watertight, in that there might be other reasons for disappointment in the sound quality, and therefore other candidates for improvement. But you have to start somewhere. In the extensive chat forums on the internet about all matters relating to hi-fi and tape, there are quite a few opinions saying that the replay electronics in the tape deck, even good ones, should be improved, together with a few people saying it would be a waste of time and effort. Amongst those who think tape replay circuitry should be improved, the commonest recommended solution was to use an external tape head preamplifier, connected directly to the tape replay heads in your tape deck and bypassing your tape deck electronics. Bypassing the existing tape deck circuitry usually means cutting into the tape head signal wires inside the tape deck, since almost no tape decks have a direct external connection to the tape heads. So this is not for the faint-hearted. So in summary, the problem is disappointing sound quality from well-reviewed, high-quality master tapes. And the proposed solution is to source an external tape head preamplifier and wire it into my tape deck. In the online forums, there's much discussion of this solution, but so far I've been unable to find anyone who's actually written up how to do it, especially in a reasonably economic and practical way. So that's what this video is about. How-to instructions on adding an external tape head preamplifier to your tape deck. So, high quality external tape head preamplifiers. You either got to buy one or build one. So let's see what's available. First, at the really cheap end of the market, you can buy tape head preamplifiers as built circuit boards on eBay. One example is shown. But these seem to be intended for low-cost, low-quality cassette decks, so I discounted them. In the moderate price range of, say, up to a few £100s, there really isn't anything available, either new or even vintage, from anyone. Lowest in the eye-watering expense category is a Titan Mark II from Earhart Audio at $1,800 to $2,100 US, followed by the Bottlehead at $4,400, followed by the Merrill at $16,000, followed finally by the Doshi at a magnificent $33,400. None of these fitted the bill for me. I'm sure they all work well, but all of them are very expensive, or worse, for a relatively simple circuit. I didn't want another sizable hi-fi box to find space for, and I didn't particularly want valve equipment. So I concluded that the best approach would be to build an external tape head preamplifier, and the best way to do that was to identify a suitable high-quality circuit. I also decided that whilst I could, in theory, design my own printed circuit board, it would require a whole new skill set, and it would be much easier to buy an existing circuit board and construct the circuit as a kit. But you can't. I found several examples of published tape head preamplifier circuits on the internet dating all the way back to the 1970s, with the Stewart high-quality tape recorder in the UK periodical Wireless World in November 1970. You could buy circuit boards for it at the time from Hart Electronics, but you can't now. I couldn't find any tape head replay circuit with a current circuit board available to buy. So time for some lateral thinking. A tape head preamplifier is actually pretty similar to a phono preamplifier for magnetic cartridges, which are still widely used for playing vinyl, and you can buy circuit boards for high quality phono preamplifiers from a few suppliers, including one from Douglas Self, a modern audio circuit expert, and his signal transfer company in the UK. A high-quality phono preamplifier design is published in Douglas's book, Small Signal Audio Design. In this case, audio high quality means state-of-the-art figures for low noise, low distortion, and high output headroom, and the assertion of high quality is amply supported in Douglas's book by actual performance measurements for the final design versus a host of possible alternatives. What needs modifying from a phono preamplifier is the amplifier feedback circuitry that changes the frequency response from RIAA equalization for phonomagnetic cartridges to NAB/IEC equalization for tape heads, which is different. The feedback circuitry for the tape head preamplifier can be made from a simple combination of a few resistors and one capacitor. In Chapter 11 of Small Signal Audio Design, a circuit is given for a tape head preamplifier based upon the high-quality phono preamplifier design. In this case, it's for tape replay at 3 3/4 inches per second. But I wanted equalization for higher quality tape replay at 7.5 inches per second with NAB or American equalization, and 15 inches per second with IEC or European equalization. So I requested help from Douglas Self, and he supplied the circuit shown, incorporating the correct component values. It is possible to calculate the values of resistance and capacitance yourself if you know what you're doing, but I wanted to be sure I had the right answers, so I paid Douglas to do the calculations. I believe it would have been a simple task for him. So now I have a high-quality tape-head preamplifier circuit to build using a high-quality phono preamplifier circuit board I purchased from the Signal Transfer Company. I had to leave out most of the components on the phono preamplifier board, such as those needed for a moving coil phono cartridge or a rumble filter, and only add the few I actually needed. I also had to add the extra resistors and capacitor for the tape equalization somewhere, so I decided to solder them onto a small, simple Vero board subboard design of my own, attached to a selector switch for equalization. The subboard was connected to the main circuit board by screen jumper leads. Here's my PCB design for the small Vero board subboard. The board was soldered to a 2-pole, 2-way switch that's in the middle at the top. The left is the left channel and the right is the right. At the left and right edges are where the screen connection wires go to the main board. The capacitor is a bit big, so it's at the extreme left and right of the other components. In a couple of cases, I've made up a resistor value from 2 other resistors. An X means I broke the copper connector on the Vero board at that point. It's a bit ugly, but it works, and it's much easier than trying to fit the new components onto the main board and adapt the phono circuit. The standard components I bought from standard UK sources such as Farnell, Mauser and Amazon. Often I had to buy multiples where I only needed one, but the costs were modest, remembering the cheapest commercial circuit was $1,800. Farnell and Mauser both have small order charges that makes items more expensive. The equalization resistors and separately some tiny capacitors came as part of a multi-component kit that are sold on Amazon. The resistors were all 1/4 watt, 1% tolerance. In one case, a critical capacitor in the equalization network, I purchased 4 68 nanofarad polypropylene capacitors with a 160 volt rating and a 1% tolerance from a supplier in Europe on eBay. They were a few pounds. Polypropylene capacitors have a higher linearity, i.e. lower distortion, than most other types, and 1% is an unusually tight tolerance for a capacitor, so it felt like a sensible investment. I also invested in an inexpensive multimeter stroke tester from Amazon, capable of measuring resistance, capacitance, and inductance, and I checked all the critical components before soldering them onto the circuit board. This was very reassuring. Obviously, a preamplifier circuit needs a power supply. In this case, a split voltage supply of +18, 0 and -18 volts. Luckily, I found a ready-made power supply circuit board on eBay, complete with mains transformer and industry standard power regulators. It only cost about £30 and it saved me a lot of effort. Before using the purchased power supply and the built preamplifier circuit, I wanted to test them both as thoroughly as I could in case of short circuits, bad connections and so on. I don't have an electronics test lab, but it's surprising what you can do with a little ingenuity. and some inexpensive modern test equipment. The preamplifier circuit is supposed to consume about 45 milliamps, which is the signal transfer company's specification. So I connected the power supply up to two high wattage 400 ohm resistors as a dummy load and adjusted the output voltage to plus or minus 18 volts using the power supply voltage adjustment potentiometers. Then I used a simple thermal camera, the Melexis MLX 90640 from Amazon that I already owned, to check nothing was getting too hot. The camera cost about £70 and is otherwise useful for saving on heating bills. Next, I connected the preamplifier to two 9-volt PP3 alkaline batteries connected in series to supply plus 9, 0 and minus 9 volts via some low-value series resistors of 350 ohms. Then I checked the voltage across the series resistors was low using a multimeter, and nothing in the preamplifier was getting too hot using the thermal camera. Finally, I connected the power supply, adjusted to plus 9, 0, minus 9 volts, to the preamplifier, and then ramped up the voltage slowly to plus 18, 0, minus 18 volts, whilst checking again nothing was getting too hot on the thermal camera. The preamplifier gain is supposed to change with frequency. This is equalization by another name. So I needed to check the gain versus various frequency inputs and measure the output was what it should be. So I bought and constructed a simple audio frequency signal generator from a kit from eBay, the XR2206, that cost an amazing £6 to £7, and also bought a simple audio frequency digital oscilloscope, the DSO-TC3, again from eBay, for a similarly amazing £37. I used a signal generator to feed a signal into the preamplifier at 30 Hz or 400 Hz or 10,000 Hz via a 1:100 resistance attenuator, so the input signal was 10 millivolts RMS into the preamplifier from a 1 volt RMS signal from the signal generator. Then I measured the output signal from the preamplifier with the oscilloscope and checked it had been amplified by the correct amount. See the table from my notebook of gain versus frequency and decibels gain versus frequency above, and also checked that the left and right channels were consistent. All this checking gave results as expected, so I had objective evidence the circuit I built was working as expected, and the power supply was working too. My preamplifier circuit and power supply are working, but now I have to cut into the existing tape deck wiring. I needed to find the wires that ran from the tape heads to the internal preamplifier board and cut into them to extract the music signal. Immensely useful was a circuit diagram I found on a website that was copied from the RS 1500 manual and showed the circuit of the tape replay amplifier and the connections to it. This showed a 6-pin connector labelled V on the left of the diagram showing on screen that connected to the tape heads. A little investigation inside the tape deck identified the replay board and the V connector, which in turn identified the two screen cables from the tape heads divided into left and right channels. I couldn't easily get access to the tape heads themselves, and anyway the connections were buried in the chassis for much of their journey. The two wires had black and grey plastic sleeving, which each internally contained a single braided copper wire sleeve for electromagnetic screening. Inside the sleeve were two wires, a pink plastic coated wire and a white plastic coated wire. The black sleeved wire was the left channel and the grey sleeved wire was the right. The pink wire in each outer wire connected to pins 1 and 6 of the V connector and was the signal, and the white wire in each outer wire connected to pins 2 and 5 and was the return or earth. At the V connector, the white wire and the earth sleeve screen, pins 3 and 4, were shorted. I cut into the wires at a location which left spare wire for connections at both ends, and then connected a twin core screened flexible signal wire from designercable.com to the signal and return wires separately by soldering them and then covering with a narrow silicone heat shrink tubing for insulation. To connect the two separated ends of the screening mesh, I used a short length of copper wire mesh from a desolder braid, expanded onto a toothpick, and then fed onto the outer wire and soldered at each end. Finally, a further length of wider silicone heat shrink tubing was shrunk onto the outside of the screened wire, and then the whole connected wire was secured into place by cable ties. The end of the wires to the tape head were fed through holes in the back of the hardboard casing to the exterior, and then RCA phono plugs were soldered onto the end for attachment to the new external preamplifier. Within the RCA phono plugs, the screening mesh was shorted to the white wire, thus maintaining the original earthing scheme in the RS1500 circuit diagram. The other cut end of the black and grey wires, which were attached to the V connector, were soldered to two RCA phono sockets mounted on holes in the back cover of the tape deck. In the middle of this wiring, I had access to the naked wires leading to the tape heads. In the RS1500, you can choose the 2 or 4 track head for replay via a switch on the front of the deck near the heads. Most advice I had read said not to measure the resistance or presumably inductance of the heads due to the risk of magnetizing them with a multimeter current. However, I confess I gave in to temptation and measured both the DC resistance and inductance of both heads and both left and right channels. The results are shown on the screen. I figured one brief measurement wouldn't be that harmful, and that I had a tape head demagnetizer I could use to undo any temporary magnetization. I haven't noticed any harmful residual effects of the measurements. Connecting the RCA phono plugs leading to the tape heads to the phono sockets mounted on the back cover of the tape deck would restore the original connections in the tape deck and use the internal replay amplifier again. So we were now ready for a bench functional test. I connected the power supply and the phono plugs leading to the tape heads to the external preamplifier. The output from the external preamplifier was connected to the input of a Bose SoundLink portable speaker via the auxiliary wired input. Then I turned on the deck, the power supply and the boats and played a 15" per second 2-track Studio Master Pink Floyd tape. And it worked. OK sound came out of both channels, so all parts appeared to be functioning.
Occasionally, glancing up through the rain.
It works. So here's the power supply functioning, suitably distant from the head amp and everything else. Walking along. The RS1500 tape deck, and at the back is the box, which is the head amplifier. Playing into the radio input on my Quad 34 preamp. And finally over to the speakers. Upon testing the new tape setup with my existing hi-fi system, it was immediately apparent there were two problems. Firstly, hum. There was an audible 50 Hz mains hum from the speakers. Very annoying. Secondly, the signal level for the high output studio tapes was just right, with the Quad 34 volume control set at 30 to 40%. But playing a vintage 4-track 7.5 inches per second tape, the level was too low, needing a volume control setting of about 60% or more. The sound from the speakers was a simple bass note at 50 Hz and wasn't a buzz at 100 Hz or a crackle from higher frequency interference. I wasn't entirely surprised because tape heads are sensitive magnetic devices, so hum can be a challenge to eliminate. A bit of thought made me realise that in cutting into the tape head wires and making them the external signal path, I'd interrupted the earth connection to the chassis of the tape deck, which normally went via the built-in phono output plug. So I connected an insulated earth wire from an unconnected length of 3-core mains cable between the existing earthing star point at the back of my Quad 34 to an earthing chassis point on the back of the tape deck, and the hum went away. The mismatch in outputs from the two types of tape I wanted to play was a bit more difficult. The level from the studio tape was just right, but from the 4-track tape was too low. I needed more amplification from the external preamplifier to be switched in when needed. A bit of research showed that all magnetic tapes have a reference recording level of magnetization, and a typical value for vintage tapes is 180 or 185 nanowavers per meter. That's a pretty complex unit, but just look on it as an index number for the moment. The box of the 2-track studio tape said the tape was recorded at plus 5 dB, decibels, above 185 nanowavers per meter, as is common with modern high output tape formulations. dB or decibels is a logarithmic scale because hearing intensity is also logarithmic. And plus 5 dB means the signal is 3 times larger than the reference 185 nanowavers per meter. So in fact is 555 nanowavers per meter, numerically a lot higher. So I needed to increase the amplification of my external amplifier also by plus 5 dB or 3 times in a way I could switch in and out. If you look at the circuit for the tape head preamplifier, the gain or amplification factor for the circuit is set by the operational amplifier feedback circuit, including resistor 5, 4, 3, 2 and 0 and capacitor C3. And the easiest one to change is R0. R0 is currently 100 ohms. Putting a 50 ohm resistor in parallel with R0 will reduce the combined resistance to 1/3 of its previous value, and therefore increase the gain of the operational amplifier by 3 times. Simples. In fact, I used a 47 ohm resistor because 50 ohms is not a standard value. The difference isn't important. The overall effect of reducing the resistance on the feedback network was not drastic because the other resistances stroke impedances were much higher, several kilo ohms or more. So I implemented the change by adding a second 2-pole 2-way switch attached to a small piece of Vero board and wired to the main circuit board via screened wires. When the switch is on, there's a 47 ohm resistor in parallel with the existing R0 of 100 ohms. And when the switch is off, it's just the original R0 100 ohm resistor. On is for 7.5 inches per second vintage 4-track tapes, and off is for 15 inches per second modern 2-track tapes. The final troubleshooting changes are in. There's no hum, and the gain level is reasonably consistent from one type of tape to another. The sound quality has improved to much more of what I expected. Our final test is that I need to find someone else with a similar crazy setup to find out if it's truly good enough. I enjoyed doing the project, which took quite a while and involved quite a few new challenges for me. The total cost was about £300, but it's hard to be exact because I have quite a few parts and instruments left over. I hope the work adds a little bit to the sum of useful human knowledge. I also naturally hope you may be inspired to give this project a try for yourself, or just possibly be put off the whole idea. Finally, I'd welcome any comments or suggestions. Thanks for watching and listening.